Today's objective is exponent rules, and these are more advanced than the ones we did on the last video. All right, remember, x to the fourth means x times x times x times x, because the exponent tells you how many times to write down and multiply the base. So let's say we have the quantity xy to the third. That means we need to write down xy 3 times, because that's our base, because it's connected to the parentheses, so it's everything inside the parentheses. Well, I could rewrite this, put all my x's together and all my y's together, and then add them up, like from up here, and get x to the third, y to the third. Okay? So because the base was inside the parentheses, the exponent was for everything that was inside the base. Here's another example. 2x quantity to the fourth. Tells me I have to write the 2x 4 times, and I'm not going to rearrange them, but I'm going to see there's 4 2's and 4 x's, so 2 to the fourth, x to the fourth, which we could simplify the 2 to the fourth to be 16x to the fourth. And I feel that it's reasonable to expect you to multiply or simplify all powers of 2. Okay, not all. If it's 2 to the 50th, you don't have to do that. But you could do up to 2 to the 7th pretty easily. And powers of 3 up to 3 to the 5th. And then others squared, sometimes to the 3rd, you know, as long as the base isn't too big. All right. The quantity of negative 4y squared. So I have 2 negative 4's and I have 2 y's. I wrote this together this way so you could be reminded that negative times negative is positive. So positive 16y squared. Notice it's positive. Well, what if I have the quantity of negative 5ab to the third power? How many negative 5's are you going to have? 3. And then ab, ab, ab. So negative 5 times negative 5 is positive 25. But then when you multiply that by a negative 5, you get negative 125 a cubed b cubed. Notice we separate out. We wouldn't write ab cubed because we'd have to put that in parentheses. So we write negative 125 a cubed b cubed. Negative bases, that's what this is, negative base, pair up with even exponents and become positive. So if we have 2, they pair up and now it becomes positive. If they have an even exponent like this 2. But with odd exponents, there's an extra one, so the answer is negative. These two will pair up. There'll always be an extra one because there's always an odd man out, and so he stands out. All right, that's just a little shortcut to remind you if the answer is going to be positive or negative when you simplify based on your exponents being even or odd. So what about division? Can we do division? What if you had a problem like this that's m divided by n, the quantity m divided by n to the fourth? Well, that tells you, hey, there's m divided by n 4 times. That's what that means. So if we combine our numerators, we get m to the fourth, and we combine our denominators, we get n to the fourth. Once again, what's inside the parentheses, you know, it's everything. The 4 applies to everything. What if I have the quantity AB divided by C squared? ABC times ABC. Well, here there's 2 A's, 2 B's, and 2 C's. That's all you have to do. Do you see a shortcut instead of writing out the base each time, instead of writing this 4 times or writing this 2 times? Here's the shortcut. Apply the exponent to every number and variable in the parentheses. So the quantity of x divided by 4 cubed becomes x cubed over 4 cubed, which we could say is 64, but we don't need to right now. The quantity of 5 divided by m squared becomes 5 squared m squared, or 25m squared. What about the quantity negative 2 divided by x to the fifth? Well, this one I showed you and then worked out, but this one I just worked out. This is how I count my 2 powers of 2. I do it on my fingers, and I double each time. So I'm not going by even numbers. I'm doubling. 2, 4, 8, 16, 32. So 2 to the fifth is 32, but because it was a negative and it's an odd exponent, it's going to be negative 32 over x to the fifth. What happens if there are exponents inside the parentheses? It's even more fun. All right, 4 squared to the third power means 4 squared times 4 squared times 4 squared, which if I broke the 4 squared means it's 1, 2, 1, 2, 1, 2, because it's 4 squared 3 times. 1, 2, 3, 4, 5, 6. It's 4 to the 6th. Look. I'll show you that in a minute, so don't look. Pretend you're not looking. What about x to the 5th quantity squared? That means x to the 5th 2 times. X, I could write all my x's out, 5x's, 5x's, and if I count them up, I get x to the 10th. Don't look at that either. Do you see a shortcut? That's what's in the black. Multiply the exponents when they're right next to each other. So now you can look. 4 to the 6th equals, when I have 4 to the 2nd power cubed, this 2 and this 3, these exponents, they're right next to each other. The 3 doesn't have its own base. It's not like you have up here a squared, b squared, okay? Those exponents aren't right next to each other. When they're only separated by parentheses, you can just multiply them. So 4 to the 2nd power cubed, 2 times 3, 6. X to the 5th power squared, 5 times 2, 10. Right? It's a shortcut. So what about, I seem to have put my finger on that, quantity of x to the negative 4 to the 5th. Well, you still multiply it. Negative 4 times 5, you get negative 20. But remember our exponent rules with negatives? We don't like to have a negative in our final answer. So we need to change the position of the base. This is in the numerator. We move it to the denominator. So the quantity of x to the negative 4 to the 5th becomes 1 over x to the 20th. 3 to the negative 4th squared becomes 3 to the negative 8, but we can't have a negative in our final answer, so it's 1 over 3 to the 8. And here's a good one. How about if I have 7x squared, the quantity of 7x squared divided by y to the negative 5th to the 4th. So it's 7 to the 4th, x to the 8th, because we multiply it, y to the negative 20, because we multiply it, but I can't have a negative in my final answer. I can't have a negative exponent. I could have a negative coefficient, but I can't have a negative exponent. So this guy has to become positive by changing its position, going up to the numerator. So I end up with 7 to the 4th, x to the 8th, y to the 20th. And also notice that your variables are in alphabetical order. And that's it.